We want to sketch in the complex plane the region defined by this. I'm just going to rewrite that as z take away 8 plus 6i. And that's between 1 and 4. This is a circle with its centre at 8, 6. Now we want two circles here. One with a radius of 1 and one with a radius of 4, and we want to shade the area in between. So it may indicate that this is 1 and this is 4. Determine in polar form r cis theta the complex number that satisfies this and has the minimum argument. So once again it's mod z take away 8 plus 6i equals 4. So if we just sketch that, here's the circle, and if we put our axes in like so, we know this centre is at 8, 6, and we know the radius is 4. Now the minimum argument is going to occur just here. Now, if we form this triangle here, it's right-angled just here. We know this is 4, and the square root of 8 squared plus 6 squared is 10, so this length is 10. The angle here, which I'll call alpha, is therefore, since this is the opposite and this is a hypotenuse, the inverse sine of 4/10. Now we'll just form another triangle just here. Again, it's right-angled here, and since this is 8, 6, this is 6, and this is 8, I'm going to call this angle theta. Theta is the inverse tangent of 6/8, and the angle we want is theta take away alpha. So we're going to do the inverse tangent of 6/8 take away the inverse sine of 4/10, and that gives us 13.3 degrees. The question was actually stated in radians, so we should give the answer in radians. So I could either recompute or I could convert. I'm just going to recompute by changing to radians here, and that gives me 0.23 radians. And we also want r, which is this length here, and we can get that using Pythagoras in this triangle. So r is going to be the square root of 10 squared minus 4 squared. And that gives me 9.17 to 2 decimal places. So r cis theta is going to be 9.17 cis 0.23.